Hello students, this is Dr. Ruchira Choudhury and welcome to Infinity Math class. If you are preparing for JEE Mathematics, then you can subscribe my channel for watching the videos related to JEE Main and Advanced in Mathematics. And today I'll solve some problems related to relation, which are the mainly PYQs of WBJEE. So let's start and solve. So let's come to the first problem. This is the first problem. On R, a relation rho is defined by x rho y if and only if x minus y is 0 or irrational. This is the definition. X rho y holds if and only if x minus y is 0 or irrational. This is the definition, and you will have to check whether rho is reflexive, symmetric or transitive. When rho is reflexive, symmetric and transitive, then rho will be said to be equivalence relation. Now, what do you mean by rational or irrational number? A number of the form p by q, where p, q are integers and q is not equal to 0, is said to be a rational number. And if a number is not rational, then the number is said to be an irrational number. So 5 by 7 is a rational number because this is a form of p by q and q is not equal to 0. Similarly, 7 by 9 is also a rational number. 3, all the integers 3, 2, 5, these are all rational numbers because 3 can be written as 3 by 1. 2 can be written as 2 by 1, which is of the form p by q and q is not equal to 0. So x rho x implies x minus x equals to 0. So that means x minus x is 0. That means rho is reflexive. So rho is reflexive. Now we will have to test whether rho is symmetric or not. Then x rho y implies x minus y is 0 or irrational. So that implies y minus x is 0 or irrational, implies y rho x. To test y rho is transitive or not. Now x rho y and y rho z, if together imply x rho z, then rho will be transitive. Now x rho y and y rho z implies together x minus y and y minus z are 0 or irrational. So that does not necessarily imply x minus z is 0 or irrational, because if 2 minus root 3 is an irrational number and root 3 minus 5 is also an irrational number, but if we add these two irrational number, that is 2 minus root 3 plus root 3 minus 5, that is minus 3, 2 minus 5, that is minus 3, which is not an irrational number, which is a rational number. So rho may be symmetric or reflexive but not transitive. This is the correct option. So let's come to the second problem. This is like that. The set of real number R, there is a set of real number R, and this is the definition. X p y holds if and only if xy is greater than equal to 0. Then the relation P is, there are 4 options are there, and you will have to test whether the relation is reflexive, symmetric or transitive. Now first, reflexive. So x square is always greater than equal to 0. So xpy, xpx holds for all x belonging to the set of real number. So it's clear from the definition that P is reflexive. Okay. Now we will have to test whether P is symmetric or not. Now x xy greater than equal to 0, I am assuming that xy is greater than equal to 0, implies yx is also greater than equal to 0. So xpy implies ypx. So this is clear from the definition that P is symmetric. Now we have to test whether P is transitive or not. Now xy greater than equal to 0 and yz greater than equals to 0 does not necessarily imply xz is greater than equal to 0, because xy dot yz equals to xy squared z. Xy greater than equal to 0, yz greater than equal to 0, but their product xy squared z can be greater than equal to 0, but this does not necessarily imply xz is greater than equal to 0. So xpy and ypz, these are the relation, and this together does not necessarily imply xpz. So P is not transitive. P is not transitive. So in these options, D is the correct option, reflexive, symmetric but not transitive. Let's come to the third problem. It's like that f is a mapping from set of real numbers to the set of real numbers such that f is injective, and this relation holds fx dot fy equals to f of x plus y, and this holds for all real numbers, for all xy belonging to R. If fx, fy, fz are in GP, then xyz are in AP or GP or AP depending on the values of xyz, and GP depending on the values of xyz. These are the four options, and you have to find out the correct option. Now at first, this relation holds for all xy belonging to R. So I can put y in place of x. So if I put y in place of x, then left hand side will be f of y whole square equals to f of y plus y means f of 2y, and this is equation 1. And now fx, fy, fz are in GP. So that means fy whole square equals to fx dot fz. That means fy whole square means f of 2y. F of 2y, this is from equation 1, f of 2y equals to f of x dot f of z. Now if we put z in place of y in this equation, then we can get fx dot fz equals to f of x plus z. So from this equation I can get fx dot fz equals to f of x plus z. That means f of x plus z equals to f of 2y. This is the equation. Now if since f is injective, so f of x plus z equals to f of 2y implies x plus z equals to 2y, that is for injectiveness of the function. So this implies x, y, z are in AP always. This is the correct option. These are the main 3 PYQs of the chapter relation of WBJEE. Now, if you want to solve more PYQs, please let me know through your comments and join my WhatsApp channel and Telegram channel, and let me know the chapters you want to discuss with me. For today's class, it's time to say bye-bye.